Okay, we're back at it. We're on day 2 now for Unit 8. We're going to go through solving systems one more day here by graphing. So the steps from yesterday, our first step is to solve, let me zoom in a little bit, to solve for y if necessary. That way you can graph easier. My next step would be graph both lines. And then step 3 is find the intersection point, and that's always your answer, wherever the two graphs intersect. Oopsie. You always write your answer as an ordered pair. That's this remember here. And it always goes x and then y. We write our answer. So those are the steps. So if we take a look at number 1, step 1 says to solve for y. Well, they're already both solved for, so I don't need to do step 1 here. Step 2 is graph both lines. So if we were to take a look at number 1, if we need to graph both these lines, the top equation says to start at 0, -5, because it's my y-intercept, and go up 2 over 1 according to that slope. So that's what we're going to do. We'll start at 0, -5, and go up 2 over 1 forever. Almost there. So now if I drew a straight line through those, it would look something like that. And then my next piece here, I know that there's a plus 0. So that means that my y-intercept is 0, 0, and my slope is up 2 over 1 from there. So we go to 0, 0, and then up 2 over 1 from there forever. Now there's something interesting that we see here when we draw our two lines. They're parallel to each other. I don't see a place where they intersect, right? So if we don't see a place where they intersect, then that means that there's going to be no answer here. So my solution is there is none. So there's no solution to this one because there's never an intersection point. So you just write no solution. Something that I noticed, and you can see these right off the bat, is if they have the same slope, so they both had a slope of 2 but different y-intercepts, then you're always going to get no solution because that means that they're going to be parallel lines every single time. So let's try it for the next one here. Let's see what we get. So this top one, if we solve for y, I'll bring it down a little bit further. So we get x plus y equals 4. So all we got to do is subtract x. So we get y equals, you can't add those together because they're not like terms. So it's -x plus 4. So that means we're going to start at 0, 4, and my slope is down 1 over 1. So we go to 0, 4, and then down 1 over 1 forever. So now, if I draw that line, it looks like this. My next one, if I subtract 2x, I get 2y equals -2x plus 8, divided by 2, and I get -x plus 4. So it looks like it's the same exact equation. So I'm going to put in a different color. So it starts at 0, 4, and it goes down 1 over 1. So it looks like these two lines are stacked right on top of each other. So there's a lot of places where they intersect, right? All those dots that are stacked right on top of each other are all places that they intersect. So it has more than one solution. So we said these ones that are stacked on top of each other has many solutions. And we're able to tell that these ones, without even graphing them, will have many if they have the same slope and same y-intercept, because it's the same line stacked on top of itself. So So that's what we got on the first page. So we have no solutions if they never intersect, and we have many solutions if they intersect a bunch of times, or if there's two lines on top of each other. So let's go to the back here. So I think that it's got two more. So for this next one, I can tell right away that they're going to have different, or that it's going to be a one solution type, because it doesn't have the same slope, right? So we saw from the first page that if you have the same slope, you're going to get one of the two special cases. It's either going to be many solutions or none, all depending if the y-intercept's the same or different. So these have a positive x and a negative x, so that means that there's a positive one and a negative one as your slope. So they should cross somewhere. So if we do the top one tells me to go through at 0, 1, and my slope is down 1 over 1. So I go to 0, 1, and I go down 1 over 1 forever. And then this bottom one looks like it goes through at 0, 7, and the slope goes up 1 over 1. So we go to 0, 7, and then up 1 over 1. So I see a place where they cross. It's right here. So we just got to write down that location. So it looks like that goes to the left. 1, 2, 3. So that's negative 3. And then up 1, 2, 3, 4. So negative 3, 4 would be my solution for this one. Let's make sure that this is still going here, sharing. All right, good. All right, the next one, if there's no number after the x, it's always a plus 0. So that means that my y-intercept is going to be at 0, 0. And for this, my slope is up 3 over 5. So we're going to go to 0, 0, and go up 3 over 5, up 3 over 5. That means we can go down 3 to the left 5 as well. Down 3 to the left 5 as well. So these are my points. Ooh, that's kind of a shaky line there. I'm freehanding these, sorry. So it looks like that. That's a pretty good line. The bottom one, if we solve for y, because y is not by itself, we get negative 5y equals negative 3x. Divide by negative 5. And we get y equals 3 over 5x. That's the same exact line. So if I put it in a different color, I know that my y-intercept's at 0, 0, and my slope is still 3 over 5, just like the first one. So it's right on top of this line. So if it's right on top of the line, that means there's a lot of places that they intersect. And we said that this would be called many solutions. So those are my 3 different solutions now. We can have one, we can have none, and we can have many, all depending on what's going on with the two equations. So we're going to recap that right here. So this has one solution if it crosses at one point. So if you get one intersection point, it's got one solution. The graph would look like this, right? So they have one single point that they cross at. To determine if it has one solution, the slopes would be different. So as long as your slopes are different, you'll always have one solution. Equation, we just did one, but I'll do a different one. So as long as the number in front of the x is different in any way, there will be one solution. So that has a difference of a 2 for slope and a 3 for the other one. So that means there's going to be one solution. So without even having to graph these, if you can recognize that they just have different slopes, you can say, okay, at least this one I know for sure has one solution. And you can get rid of the two possibilities on a quiz or test that say many or none if the slopes are different. So then you can cross out 2 out of the 4 right away. All right, next, the system has no solutions if they never intersect. So if the lines never intersect. So these are the ones that run parallel to each other. So a picture of that would be something like this. If we had 2 lines that run parallel to each other. To determine if they have no solution, the slopes are the same and the y-intercepts are different. So an equation, a system that might look like this, where the slopes are the same, but the y-intercepts are different, you'd make sure that the numbers in front of the x are the same, but the numbers after are different. That would be a no solution type every single time. And let's go on to the many solutions type next. All right, so it has many solutions if the lines are on top of each other. So if you get 2 lines that are on top of each other, that means that you're going to have many. So it would look like this, where the blue line and the green line are directly stacked. So if the equation has many solutions, the slopes are the same and the y-intercepts are the same. So this is different from the last one because we said the y-intercepts were different. But in this case, they're going to be the same. Here's an example. 2 of the same exact equation. And let's remember to always solve for y. So that you can see these, the slope and y-intercept very easily. So just solve for y. All right. So it says identify if these systems have one, none, or many solutions without even graphing. So we're just going to use those 3 pieces that we just learned. So we're going to look at the slope and the y-intercept for each one of these. So we just got to solve for y. So for this one, if we solve for y, we would add 3x over to the other side. We get y equals 3x minus 4. For the bottom one, we got to add 6x over to the other side. And then divide by 2. So now we look at the slope and the y-intercept of them. They're both the same slope and the same y-intercept. So that means these 2 lines are stacked on top of each other. So there's many solutions. How did we know? Same slope and y-intercept. That's how we knew. Number 2, let's do the same thing. Let's solve for y for both and see what we get. So now we get 4y equals negative 2x plus 8. Divide by 4. And we get negative half x plus 2. So for this next one, divide by 2, we get negative half x minus 1. All right, so if we take a look at this, they have the same slope, but different y-intercepts, right? So if you have the same slope but a different y-intercept, that means those 2 lines are parallel to each other. So that means there's no solution. same slope, different y-intercepts. Or you could have written parallel lines. Some people like just to say what the lines look like. So that covers the second one. We got two more where we have to solve for y and see what the slope and the y-intercept is of each. So let's move up. So for this one here, the top, subtract 12x. Divide by 3. Add 6. So these have different slopes. So that means there's one solution, because the slopes are not the same. So it can't be parallel or the same line. So how do we know? Just different slopes is all we got to write. They're just going to intersect at one point. Then the last one, we have to solve for y. So we got negative 3/2 x plus 4. And then for this one, we got 5x plus 4. So that means that the slopes are different. So there's only one solution. And we know that because there's different slopes. So I think that that covers everything that's on day 2. Tomorrow, I'll see you. Have a great day. If you have any questions, reach out to your teacher. Take care.